2.5 Chain Rule Part 1. We have a couple of problems we're going to consider in this video. First of all, z equals x squared plus y, x equals 2t, y equals 3t. And we want to find dx dt. Z is a function of x and y. X and y are both functions of t. And there are times when it's useful to know how z is changing with respect to t. If t is time, dz, sorry about that, that's supposed to be dz dt. dz dt would give us vertical velocity, for instance, change in elevation with respect to time. So that's what the physical relevance of this would be. Well, one method is we can make a direct substitution. Z equals x squared, x is 2t, so we get 2t quantity squared, and plus y, which is 3t. And of course, we can square that, and it gives us 4 times t squared plus 3t. And then dz dt is just a simple calculus 1 derivative. Derivative of 4t squared is 8t, and derivative of 3t is 3. It's just as simple as that. We also have a chain rule for these multivariable functions, and we can develop a chain rule by using this tree diagram. Z is a function of both x and y, x is a function of t, y is a function of t. And it turns out each of these paths gives us one term, and each of these individual nodes, I guess you can call them, represent a partial derivative. This partial derivative is z subscript x. This partial derivative is dx dt. And this one is partial of z with respect to y, and this is dy dt. We don't call this a partial derivative, dy dt, because y is only a function of one variable. So, but you can call this partial of z with respect to x if you want. That would be, and this of course would be partial of z with respect to y. So let's test out our theory. Keep in mind we should get an answer of 8t plus 3 in any event. And so we have dz dt, if x and y were both functions of s and t, for instance, then this would be a partial derivative. But z is only a function of one variable, so we just call this a normal derivative, dz dt. Well, we're going to go in this direction, partial of z with respect to x times dx dt plus partial of z times dy dt. Okay, and partial of z with respect to x is just plain 2x times dx dt, that's a very simple derivative, 2, plus partial of z with respect to y, that's equal to 1, and dy dt, that is just 3. Okay. Now, of course, if we're finding dz dt, we probably want this as a function of t. These intermediary variables probably aren't that useful. But you'll notice x is equal to 2t. So we have 2 times 2t times 2 plus 3, which is 8t plus 3. Same as before. Okay. It gives you the same answer. There are advantages to having this formula. In part 2, we'll look at an example where these chain rule formulas are necessary. For doing these simple problems, probably doesn't matter which way they're done. Now here's the second problem. Z is a function of x and y. X is a function of u and v. Y is a function of u and v. And we want to find partial of z with respect to u, and also partial of z with respect to v. They're partial derivatives because z ultimately is a function of two variables at this level. We can develop a tree diagram right here in the middle. Does much the same thing. Z is a function of x and y. X is the function of u and v. Y is a function of u and v. And now we can develop a formula. Let's start with partial of z with respect to u. Well, notice these u's here. There's two different paths that can take us from z to u. Each path will represent a term. Partial of z with respect to x times partial of x with respect to u plus partial of z with respect to y partial of y with respect to u. And now, of course, we can fill in these derivatives. Partial of z with respect to x is 2x times partial of x with respect to u is 1. That's a times. Partial of z with respect to y, go back here, that's 4y. And partial of y with respect to u, that's another 1. And like before, we probably want this in terms of u and v. So x we can put in u plus v. We get 2 times u plus v. You can skip the 1. Plus 4 times y is equal to u minus v. And that's 2u and 4u is 6u. 2v minus 4v is minus 2v. Okay, I'm going to write this up here. Partial of z with respect to u is equal to 6u minus 2v. We'll just make a record of that so that we have that for later on. Now we want to find partial of z with respect to v, so we're going to work that out. And we don't have to redo our whole tree diagram here. Okay, there's a v, so we have a path to go this way, path goes this way. That'll give us two terms. Partial of z with respect to x times partial of x with respect to v plus partial of z with respect to y times partial of y with respect to v. As a check, you can mentally cancel out these partial with respect to x's, and notice partial of z with respect to v, you have one there and one there. You technically can't cancel these out because that would give you partial of z with respect to v equals 2 partial of z with respect to v, and that relationship wouldn't be true unless this was 0. So, but mentally, it's a good mental check to see if each of these terms give you the proper derivative. Of course, you have an x here and a y here. If we had another variable here, and that variable is a function of u and v, we just have another term. So it's a good visual check. Well, in any event, partial of z with respect to v is a partial of z with respect to x, 2x. Partial of x with respect to v is 1. And partial of z with respect to y is 4y. And partial of y with respect to v is minus 1. And we get 2x, 2 times u plus v, minus 4 times u minus v. Negative 1 times 4 is negative 4. And that gives us 2u and minus 4u is negative 2u. And then 2v plus 4v is 6v. And so we have partial of z with respect to v is equal to negative 2u plus 6v. Okay, that's a couple partial derivatives. Like before, we can always use direct substitution in this case. So z is going to be u plus v squared plus 2 times u minus v squared. And we can FOIL that out. We end up getting u squared plus 2uv plus v squared plus 2u squared minus 4uv plus 2v squared. Do FOIL. I did FOIL. I distributed the two all in one step. And we get 3u squared. 2uv minus 4 is minus 2uv. V squared, and that is plus 3v squared. And you can check partial of z with respect to u is 6u. That's this term right here. Okay, and this term 2v is a constant. That's the variable, so it's minus 2v. That's this term right here. V is constant, that term goes to 0. Partial of z with respect to v is equal to, we want to differentiate this with respect to v. That goes away, we get negative 2u. That's this term right here, and we also have to differentiate the 3v squared, so we get plus 6v. Okay, and that's what we get right there. So. Okay, that's the end of this video. We'll be back with part 2 shortly. We'll look at an interesting problem.